Your plant looks fine. That's the problem. Right now, under the soil line, a hidden distress signal might be firing through the root zone of your favorite plant. And you won't see a single symptom for weeks. You've been trained to believe roots are passive, silent, just sitting there in the dark, soaking up water like a sponge. They're not. We've lined up macro footage and time-lapse sequences to show you exactly what's happening down there. The actual electrochemical signal your plant fires when it's in trouble. And by the time you see a yellow leaf, that signal started 2 to 3 weeks ago. You just weren't watching the right footage. Today, we're decoding that signal and showing you the exact diagnostic protocol to catch it before the rot becomes irreversible. Let's start with the healthy baseline. Picture the root zone as a microscopic metropolis, root hairs extending into the substrate, mycorrhizal networks acting as underground supply lines, oxygen flowing freely through the pore spaces in well-draining soil. This is peacetime. Now, the problem. Overwatering, compacted substrate, a pot with poor drainage. Suddenly the air pockets in the soil flood, oxygen levels collapse. Anaerobic bacteria, the kind that thrive without oxygen, start multiplying in that suffocated zone. This is where most collectors completely ruin their investment, because nothing looks wrong yet. Inside the root, cellular energy production is already failing. ATP, the energy currency of every living cell, starts dropping fast because the mitochondria need oxygen to make it, and that's the trigger. The root fires a calcium signal, a wave of Ca2+ ions rushing upward through the vascular tissue, the plant's internal plumbing system, like an electrical flare. Some studies describe a parallel burst of reactive oxygen species alongside it, acting almost like an internal biological warning light. Here's the mechanism. Most content skips entirely. This signal moves fast. This isn't a slow chemical drip. It's a rapid systemic alert in an organism that supposedly doesn't have a nervous system. The leaves receive that signal before you do. Stomata, the microscopic breathing pores on the leaf surface, begin closing to conserve water and energy. Growth slows. Metabolism shifts into a defensive, low-power mode. All of this happens while your plant still looks green on the surface, but it gets more counterintuitive. Most standard advice tells you to just water less, or move it to more light. That's a surface-level reaction to a root-level problem. Here's the actual mistake most people make: pouring a generic chemical fertilizer or a store-bought root revitalizer onto a plant that's already suffocating. Pouring nutrients onto a suffocating root system is like handing a drowning person a protein shake. It doesn't matter how many nutrients are in it if the roots can't breathe. That's the negative economic loop. You spend on a product that treats the visible symptom, a droopy leaf, a slow yellow. The plant temporarily perks up. The underlying oxygen deficit remains untouched. Weeks later, the same problem resurfaces, except now the root damage is more advanced, and reversing it is significantly harder. The real failure point isn't the leaf, and it isn't the fertilizer bottle. It's substrate structure and oxygen availability. The thing almost nobody actually inspects until it's too late. Here's the exact protocol, step by step. Step 1. Diagnose oxygen availability. Correctly. Skip the cheap metal probe moisture meters. Here's why. Those cheap probes measure electrical conductivity from salts in the soil, not actual water content, which is exactly how people end up overwatering already compacted soil while the meter tells them it's dry. Instead, use a digital capacitance-based moisture meter, which reads actual moisture, not conductivity. No meter on hand? The wooden chopstick test works just as well. Insert it deep near the root ball, and if it comes out with wet soil clinging to it after the surface has already dried, you've got a drainage problem, not a watering problem. Step 2. Rebuild the substrate architecture. And yes, this means an emergency repot. Top dressing will not fix this. If the root zone is already anaerobic, the compacted, waterlogged soil around the roots has to physically come out. This is a bare root rescue operation. Gently remove the plant, rinse the compacted soil away from the root ball, and trim back any dark, mushy, or hollow-feeling roots. Those are already dead, and will only reinfect the healthy tissue if left in place. Then repot into a fresh mix heavily cut with porous pumice or perlite. Aim for a 1.1 ratio of standard potting soil to drainage medium. That's roughly equal parts by volume, not a handful tossed in. At that ratio, the mix physically cannot compact back down the way it just did. Think of it as reopening the highway lanes that got shut down and making sure they can't get blocked again. Step 3. Address active pathogen load with a named, specific intervention applied correctly. Once the plant is repotted, water it in with a beneficial microbial inoculant. Strains like Bacillus amyloleak faciens or a mycorrhizal fungi blend are the ones most commonly studied for suppressing root pathogens and helping the plant recolonize its new soil. Mix it into your watering can for that first post-repot watering, so it makes direct contact with the root zone while the soil is still settling. These work with the plant's own defenses rather than against them, unlike a broad synthetic fungicide drench. Step 4. Monitor the vascular recovery. Watch for stomata reopening. New leaf growth resuming at a normal rate is your clearest sign the internal alarm has stood down and the plant has shifted out of defensive mode. This isn't guesswork. It's giving the plant back the physical conditions its biology requires to stop sending distress signals in the first place. Your plant was never silent. It was signaling the entire time, you just didn't have the translation or the footage to prove it. Work with the biology, not against it. Correct diagnosis, physical repot at the right ratio, targeted microbial support at the right moment, and the alarm shuts off on its own. Next, we're going deep into how your plant actually breathes, the hidden pore system it uses to trade gases with the air, and why just give it light misses the real mechanism entirely.